All right, let's get to it. The recording is started and we are looking into unit rates. That's a special word. If I were to make this super obvious, today's lesson is literally a unit rate, which means, remember ratios yesterday? A unit rate is literally a ratio of a certain number, that's right, ratio, right, to 1. That's it. You figure out whatever the ratio could be. It could be like 5 to 2. Well, what would that be if I wanted that ratio to be with 1? That's a unit rate. Whatever is on the denominator, for example, it's going to be a 1. That's the lesson for today. And how do you get there? Well, that's literally up to you how you want to do that. If you want to use logical reasoning or if you want to use algebra. But of course, me being the math teacher, in case that there are more difficult questions that are thrown at you, I'm always going to push the algebra method. All right, so let's talk a little bit about this. Unit rates. A rate is a comparison of two quantities. Sounds familiar? That's what a ratio is. Measured in 2 different units. For example, when someone describes how fast a car is going, take a look at the units we're using. The car is traveling at some unit divided by another unit that has nothing to do with a measurement of distance. This is a measurement of time. That's all it is. 2 different units. When describing a rate, the word per is used, which makes sense, right? 100 kilometers per hour. It's read as 100 kilometers per hour. So far, so good. Any questions? I'm hoping not. It's not supposed to be a trick question. We're looking at how ratios can be applied in a very easy way. Let's take a look at some examples. Here it is. Typically, speed is the most common thing. Also, as you become, I guess, you become 15 this year, next year 15 on 16, you can technically hold an official job, right? If you want, just to make some side money. The next rate that you might be interested in would be how much money you make per hour. Yeah, that's all it is, right? So you've used or you have heard of these terms already. A snow leopard runs 100 kilometers in 15 minutes. How many kilometers does a snow leopard travel per minute and then per hour? So again, they give it to you in minutes. So it's easy, it's going to be easy to calculate per minute. But if they ask you to create a unit rate per hour, well, you will see how we can make that change, right? Because they are different, obviously, we're going to have to do something about that. Let's start with per minute. How many kilometers? Well, here it is. Let's write it like this. I have 10 kilometers compared to 15 minutes. And the goal is to turn this into a unit rate. That is, how many kilometers would it be if I were to compare it to every one of these units? Again, it could be a minute, it could be an hour, it doesn't matter. So how do we go from here to here? I'll demonstrate this first part. Again, algebra is in the works, right? I don't want, or my goal, as I said, I'm going to try to push the algebra agenda. My goal is to get X all alone, right? So if I were to do this mathematically, so as an algebra question, it would be 10 over 15 equals X over 1. Now, again, my goal is to get X all alone. It's being divided by 1. How do you get rid of a division of anything? Yep, right, except it's already a 1. Does anything change if I multiply it with a 1? No. So in fact, 99% of the time, a unit rate question is already set up for you algebraically. All we have to do is solve this fraction because x is already all alone. So what's 10 divided by 15? Yep, 2/3, right? So this would be equal to 2/3, or since we are talking about an application, right? You can say that it is 0.66 repeating. What does that mean? Therefore, so how about I round it to, right, well, yeah, so the reason why it says it shows 7 is because a calculator is rounding. A 6 would go on forever. So I'm going to round it ahead of time because I'm not interested in too many decimal places in this particular question. So I would say, therefore, the snow leopard travels at 0.67. And what does the X represent? Kilometers per 1 minute. And notice how when we talk about it in English, I don't need to write 1 minute, it's just per minute. It's assumed it's a single one. That's it. So again, as I said in my whiteboard, algebra is there. You just don't see it because it's already set up nicely. Here's the next one. Please read the question carefully. How many kilometers is it going to travel per hour? I need to figure out what 15 minutes is per hour. Some people might use their common sense. Some people might remember how to convert units in science class from their electricity unit. Sorry? It's true. So the proper quote unquote mathematical way of converting a unit is we're going to multiply it by 1. Right? Because if you multiply it by 1, you don't change the actual value. But notice what my 1 is. My 1 is 60 minutes to 1 hour. Would you agree that the numerator and the denominator are equal in value? That's the issue. So when I multiply this, the units will, I'm going to say, just going to cancel out.
Why couldn't you just do 0.67 times
0.67 times 60? We're looking at different units right now. You're looking at this unit measure, a unit rate per minute. I want to try to calculate it again, but this time it's going to be X kilometers per hour.
But every time we have something in hours, it's also in minutes.
Yes. However, the fraction that we use, the ratio that we use, it wouldn't be 15 hours. How many hours is 15 minutes? That we have to do that conversion first. Yeah. So you just bear with me. Yes. Right. So because, but we don't want to multiply, but you're right. You're right. We know that it's 15 times 4 equals 60. So it's basically 15 minutes is a quarter of an hour. So again, you could use your logical reasoning, but just in case I give you some obscure number, like what if I told you like 7 minutes? How many hours is that? You know what I mean? So I want to show you that we're multiplying by 1. And when I do so, 15 times 1 is 15. And then of course, 1 times 60 is 60. The minutes are gone. All that's left is an hour. We have 0.25 hours. The numbers are nice, so you get yourself a quarter of an hour. But if the numbers weren't nice, this is a good way to make sure you're doing it correctly. Yes.
I have a question. For this question, could you figure out how many kilometers in snow hours travel, like how many minutes, like 0.67 times 60, and then figure out from there how many hours that is?
Yes. Yes, you can.
Wouldn't that be
Maybe. But again, I just wanted to demonstrate what if you didn't necessarily have that per se, right? I just want to show you how unit conversions can be done. I wanted to take that opportunity. That's not to say you have this and you're like, oh, just multiply by 60 and you got it. Like, yeah, you're right, right? So I'm going to say this time I can travel 10 kilometers every 0.25 hours. So how many kilometers is that every 1 hour? Again, if I were to translate this into an algebra question, this would be 10 over 0.25 equals x over 1, which is just x. And all we have to do is plug that into the calculator, because x is already all alone, and we're happy. 10 divided by 0.25, assuming everyone has a calculator in front of them, would be 40. Therefore,
Okay, so when I first did it, I did 0.67 times 60, and it was 40.2.
it's because your calculator has rounded. Try this, 0.06666666, as many 6 as possible, times the 60, and you'll get 40.000000 something.
So it's 0.69.
Times 60. Try it.
39.999.
Yeah. Yeah. So again, it depends. Again, that's the idea of infinity. If that went forever, it would be 99999999999, which is.
And what if it's 40.2? You could drop that.
I am going to ask you to, if that's the case, don't round, but use the answer button in your calculator. Because that answer key in your calculator will save the 6666666 and assume that goes on to infinity. They'll give you the actual answer. Should I show you? Here. Okay, let me see if I could wrap this camera around. And this is good, right? It gives you an opportunity to see how technology can be limitless or very limiting. Let me see if I can stop this share. And I hope it doesn't remove all of my stuff. Where is it? Oops. Oh, that's what it is. Okay, here we go. All right, so this is my calculator. Everyone see it? Yeah? So I am going to do 2 divided by 3. And I get 0.667. Yes, it rounds for me. However, even though it's rounding for me, the computer, particularly your calculator, will probably have saved 0.6 like up to infinity. So I'm going to take this answer, that's why I love the answer key, and multiply it by 60 minutes. It will give you 40 on the dot, because the computer still assumes infinity. So.
Also doesn't show.
Yeah, well, that line on top of the 6 means it's repeating forever. So it's good.
Okay, but you don't need to write the 7.
No, only at the final answer, you would round it because it makes it more practical for human use, I suppose.
Like 0.6 infinity, that was the question around. Would you say 0.67?
Nope, well, yes. In mathematics, you can just leave it as 2.2 over 3. However, if we are in a story, if we're doing it as a word question, it would be important to round it because it's more useful.
I pressed the button again and it does this.
Sure. All right, let's talk about this. So the examples are going to be very straightforward. Again, I give you a ratio, I give you a proportion, and you're going to have to figure out the unit rate. So hopefully you have your sheets in front of you. You have a pencil. 78 students in. Everyone's been taking them. Here, use this for now. It's like a weird thin pencil. Oh, there it is. Okay, and so that is how many students per one class. Mathematically, again, I hope you can see without rewriting it that the fraction is, or the ratio is 78/6 equals x over 1. Right? So yes, there's algebra, but there's no change if you multiply both sides by 1. So all you have to do is do 78 divided by 6. So x, therefore, equals 1, 3. So there are 13 students per class is the unit rate. At a certain point, I'm going to start getting lazy writing the unit rate. So I hope you'll understand. Okay. Maybe I can turn off the video now. Let's keep going. It's the same. 1,210 liters leaked out of a pool in 3 hours. So we have 1,210 liters every 3 hours. What is that in terms of liters per hour? Of course, that's a 1, but I think you start to see why people don't write the 1, because is there really a point? That's why we write it like this, because we know it's a 1, it's automatically assumed. But any case, so you divide that, it becomes 403 so there it is, 3.3333333 repeating, right? And so mathematically, this is the correct number. Human-wise, right, like application-wise, do we care about the 333 infinity? No. So you could say something like about, see the keyword, about 403.3 liters per hour is the unit rate. Again, mathematically, this is the correct final answer. Realistically, you can round it because we don't care about the infinity in real life. I'll do a couple more. Yes. Right now? Something that's happening? Okay. Everyone, would you try the C and D? Okay. So again, I'm hoping that you will see the applications to this. It's very straightforward. Right? It just makes more sense for us to read or communicate comparisons of numbers as a unit rate, because it's so much easier to process in our minds. So this is how many kilometers for every 1 liter? Again, the division of 1 doesn't change anything. So it's literally 850 divided by 63. Right? That's all it is, mathematically speaking. And then we will attach the kilometers and the liters after. So 650 divided by 63, I mean, it's 850, Rahan? 1 point? Okay, is that right? 13.5. Yeah, I got 13.49. Just double check. Yeah, you might have just put in 85. Yeah, it's just a unit, it's just a 1 decimal. So we got 13.49. I just round it. Yeah, 13.5 is a nice one. I'm not a stickler right now for proper rounding. So x is equal to 13.5. And so the unit rate is 13.5 kilometers per liter. Question? Yes, you may. Now, fun fact, car brands use unit rate as well, but not necessarily a unit rate. They do use a rate. If you've ever been interested in cars, or you've heard parents or guardians or older, like, siblings that can actually afford a used car or whatever, if they talk about it, they usually talk about mileage, how much you can travel on a tank of gas. Anyone know what the unit they use for that? Yep. Miles per gallon. Not, oh yes. So yeah, in the States, it will be miles per gallon, right? But also, instead of actually miles per gallon, sometimes they change it up. People are more interested in how much gas that they need for every 100 kilometers that they drive. So the units are actually switched. But that's okay. All we would have to do is put the 63 on top and the 850 on the bottom. It all depends on how you want to communicate it. But that's all it is. There's nothing different with the math. It's just how you want to interpret. So nowadays, like hybrid cars would be what, like 6 or 7 liters of gas every 100. It's really good. Minivans would go anywhere from like 10 to 15. If you get yourself a Hummer or those gas guzzling cars, it might be like 20 liters, which is ridiculous, but whatever. What do I know, right? Lastly, and this is what you would probably be most interested in when you get your first, job. Who's to say that you actually get an hourly job versus, you become like a freelancer, because you guys are so much more internet savvy than I am. Or you might have already set up a Shopify account. I don't know. I've had a grade 9 student do that because his parents were in import export. So he started doing stuff with soccer and he's raking it in, but he still wants to go to university because he wants to take courses for finances. I guess that's his goal, right? Pretty cool. So how much money is that per one? Mathematically, we don't need the dollar sign. We don't need the units of 1 hour. It's just 140 divided by 4. Go ahead. X equals? Correct. If X is 35, that means the entire unit rate would be 35 per hour. Good. That's it. What I would be expecting is write a kind of a statement comparing to, and then solving it after. Okay, so let's take a look at our other examples. I think you should be able to figure out most of these, but I will go through it slowly anyways. Here we go. Oh, actually, let's go a little faster. Ready? Ellie buys, nothing to do this, Ellie buys 8 calculators for $120. Each calculator costs the same amount. So how much does one calculator cost? So from this, it's not necessarily the math that might be complicated, but you also have to consider, if I'm trying to find out how much one calculator costs, is it easier to do number of calculators per $1? Or is it better to do number of amount of dollars per one calculator? You decide. But I hope that you notice that the denominator is always going to be a 1. So if I'm looking for one calculator, put that on the bottom. We have $120 per 8 calculators. So how much money is it per one calculator? Plug that in. It is 15. Therefore, one calculator costs $15. Right? Again, I guess the takeaway from that is, which one are you looking for? Either one is correct, but one is more useful to you because I want to find how much it is for one calculator, not how many calculators can I get for $1, right? I think that makes sense. Very quickly, if I know that my unit rate is $15 per one calculator, well, how much money would it cost for 13 calculators? So I'm doing a little bit of a reverse. If I already have the unit rate, what would this be? Straightforward. 7? 195. How'd you get that? Here it is. So this is what I mean by the algebra. Some people are like, oh, 1 to 13, we'll multiply by 13. 15 to unknown, multiply by the same thing. But I'm going to try to push you to do this in the algebraic way. I know I'm being so annoying, and so as your generation might call it, extra. Okay? But please, I hope that you will entertain this idea. I want x all alone. How do I get x all alone? So instead of doing what you did, Zephin, can you do it my way? How do I get x all alone? How do I get rid of a division of 13? Say the exact same thing you just told me. 15 times? Well, yes. Why did you choose 13? What you're using your intuition, which is not a bad thing. But as the numbers gets harder, intuition might fail you because it gets more complicated. If you want to get rid of the division of 13, you have to multiply by 13. And if that happens, you do it to both sides. That's why 15 times 13 works. And so this is canceled or divided into each other, giving you a 1. 15 times 13 is 195 on the left side, and on the right side, I'm left with just x. You found x. Therefore, 13 calculators will cost $195. Yes?
I might have complicated it a little bit. I didn't divide either. I just did, basically what I did was I did 13, and then I just subtracted it. I subtracted 8 from 13, which is 5.
Mm-hmm.
And then I times 5. I times 5 by 15.
That is totally doable. You figured out how much it would be for 1. So you need to add 5 more calculators. Yeah. So 8 calculators plus 5 calculators is what you did. You know this is 120, and you know this is 5 times 15. Yeah, that's totally doable. Yep, absolutely. So because we'll see if that method works for the next one. The next one is a little funky. Take a look at what I'm given. I'm going to clear this for a second. How many calculators will Ellie be able to buy with 540? So again, my unit rate is $15 for 1 calculator. This time they give me the money value. They're asking for how many calculators there are. Yep.
So you divide by 15.
Essentially, but why does that make sense? Algebraically, there's an explanation for it, and I'll try to explain here. Don't want to, so mathematically, this is 15 equals 140 divided by x, because division of 1, it doesn't make a difference. How do I get x all alone? Firstly, let's get rid of the fraction, as I always say. Let's get rid of the denominator. I'm going to multiply both sides by that denominator and essentially turning that into a 1. My next line would be 15 times x equals 540. And then Maddie's like, well, I just divided by 15. This is why. If I divide both sides by 15, I can get x all alone. 15 divided by 15 is a 1. And 540 divided by 15 is 36. If I had $540, I can get 36 calculators. So this is why, instead of trusting just intuition, I believe it is helpful to learn the algebra behind it, because if the numbers start getting really complicated, you will be very happy you spent the time doing it this way. So I hope you will entertain that idea. Okay. Any questions? We're basically done. I'm just going to demonstrate one question for you for comparing rates, because it's nothing new. I just want you to know that it's not a trick question. You might think this is very simple, Mr. Kim. Are you sure this is how I'm? Yes. Okay. Comparing rates. Now that we have an understanding of unit rates and how that could be helpful, it's your choice whether you want to use the unit rates or not. So let me do it the way that I would have hoped you to do it. I hope you would do it as well. But if you do it a different way, well, that's fine. You might find though that it may not be the most helpful as you get to questions like number 3 and number 4. Here we go. A. I'm going to pause this video. Could you try calculating the unit rates for A and B, please? Well, speaking of wrapping, how do you like the table? How do you like the table?
Oh, yeah.
It's not bad, right?
I didn't even notice that it was like.
I did it for you, Maddie. I did it for you. All right, here we go. I tried, but it's still paper and tape, so I might have to do it like every month. Anyways, all right, everyone. 6 for 540 is your choice. Do you want to do how much corn per $1, or do you want to do how many dollars per 1 corn? It's really up to you. For me, being someone who does go grocery shopping, for me, it makes sense to do how many corns can I get for, how much is 1 corn? So I'm going to do 540 per 6 corn versus B is 220 per 2 corn.
Wait, but couldn't you do the same thing for B that you could for A? Like, could you just do 2 corn over?
Yeah, absolutely. That's what I mean. You could do it whatever way you want. But for me, it just makes sense for me to say how much money is it for 1 corn. It just makes sense in my head. You can do whatever you want. So knowing that I'm looking for X over 1, with all the practice you've done in the previous examples, I'm pretty sure you understand that you just take these 2 fractions and dividing it. We divided that fraction every single time. $5.40 divided by 6 gives you 90 cents per 1 corn. 220, how much is it per 1 corn? It would be $1.10 per 1 corn. So assuming both of these corns are identical, they're all from the same batch, they're from the same farm, they're the same age, blah, blah, blah. Which one's the better value? Yeah, cheaper, right? You're getting the same stuff for 90 cents per. Obviously, the only difference is you have to buy more. But again, when I'm asking for better value, it simply is which one has the better unit rate. Okay, better unit rate. So I'm going to assume better value.
You can kind of tell based off the examples that are given.
Right,
Like,
right.
The question is just asking what's the better value and not asking you to show how you got it. It's literally times the 2 by 3.
Yes. You are correct. Especially if you have the number sense, you can see that this is going to be more expensive than this. How would you tell? Well, think about it in terms of, don't write it here. Think about it in terms of fractions. How do I make the denominator the same? Right? Right? Times 3 over 3, right? This would be 6.60 over 6. Obviously, this is more expensive. You could do it that way, absolutely. Stefan, you're looking at me like I'm crazy. Question? No? Okay. You could do it this way, but I want to push you to go and calculate the unit rate of both because sometimes it will not be obvious. So get into the habit of using unit rates. You won't regret it. At least that's what I'm going to say. All right. All the other examples, numbers 2, 3, and 4 are exactly the same. I give you 2 different circumstances. Can you find the unit rate and tell me the better value? And that's it. Practice is important. The mathematical concepts are not too complex. If you keep on working at it, it will slowly become solidified and permanent in your brains, I hope. But it does require you to put some work in, put some hours in. All right. Any questions? Okay, let's try the other questions that I provide for you. There are a lot of homework questions. We do have a good 30 minutes before we go. So if you want a good sprinkle, try, 1, 3, 5, 7 kind of thing and move on from there.